in this question, we have a function f of x, and we're given the derivative f dash, or in other words, we're given dy by dx is equal to this expression here. And they're asking for the values of x for which the curve is stationary. Now, they're looking for stationary points. So these are also known as turning points. So these are points where the curve is either at a maximum or at a minimum, or possibly inflection points. And what's common about these stationary points is that dy by dx is equal to 0. So the derivative is 0 at these points. So they're asking for the value of x for which the curve is stationary. So basically it means the derivative here should be 0. So we can start by taking this and equating it to 0. And basically that's what we're trying to solve. We're trying to solve the equation where that is equal to 0. So the first challenge you have in solving a question like this is dealing with a denominator or a variable in the denominator. So the best way to get rid of a variable in the denominator is to multiply both sides of this equation by that denominator. So if you multiply both sides by x squared, we can effectively eliminate x squared from the denominator. So the right-hand side will just be 0. And on the left, you'll have x squared multiplied by square root of x. And if that isn't clear, let me clarify. If you have x squared times square root of x, that's like saying x squared times x to the power half. And when you multiply, you add the powers. So it's x to the power 5 over 2. So that's our first product there. So let me just clear the way for that. So x to the power 5 over 2 minus 243, because that will go with that, equals 0. So take 243 to the other side. So x to the power 5 over 2 equals 243. Now we want to find x, so we want to get rid of that power. The easiest way to get rid of a power is to raise both sides to the power 2 over 5. 2 over 5 being the reciprocal of 5 over 2. So that when you multiply powers, you get 1. So 5 over 2 multiplied by the reciprocal 2 over 5 equals 1. So x to the power 1 equals 243 to the power 2 over 5. Now if you put that in a calculator, you get 9. So 9 is the value of x for which the curve is stationary. And we can test that, we can check that really easily. We can just take x equals 9 and put that into here. So if we were to find f dash of 9, if you substitute 9 here and 9 here, you'll find that you get 0. So that's correct. So we found the value of x that makes the curve stationary. Now the question goes on. Let me just copy this. The question goes on and says, determine whether that stationary point that we just found, is it a maximum, is it a minimum, or is it a point of inflection? So how do we tell if it's a maximum, minimum, or point of inflection? Because in all the cases, f dash is going to be 0. So what's the difference between a maximum, a minimum, and a point of inflection? Well, the difference is in the second derivative. So that means the derivative of the derivative. So the second derivative can either be positive, 0, or negative. And this will be at the point where x equals 9. So we find the second derivative, we substitute the value we found, x equals 9, and we check, is it positive, is it negative, or equals to 0. Now, if the second derivative is positive, we know that the point was a local minimum. If it was negative, we know the point was a local maximum. And if it was 0, we know it's a point of inflection. So, if we start with our expression for the first derivative, that was our first derivative, f dash. The second derivative, let's rewrite that actually, because nobody likes surds, nobody likes x in the denominator. So that's x to the power half. Let's make space. So that's f dash equals x to the power half minus 243 times x to the minus 2. So notice x squared in the denominator becomes x to the power minus 2. So if we differentiate that again, f double dash, you multiply by the power, so that's 1/2, and then you subtract 1 from the power, so x to the power minus half. And then you multiply minus 2 times negative 243, that gives you plus 486 x to the power negative 3. And then you find what the second derivative at the point 9 equals. So we replace x with the value that we found, 9. So that's going to give us half times 9 to the power minus half plus 486 times 9 to the power minus 3. Now you can put that in your calculator, but it's clearly going to be positive because that's positive and that's positive, and there's a plus sign between them. So it's going to be positive. So we're going to say the second derivative is greater than 0. Therefore, we have a local minimum. Now the question, which we've now answered, asked, determine whether this stationary point is a maximum, minimum, or point of inflection. That's a very helpful way of asking the question. You might find a question that says, determine the nature of this turning point. So they might just say, determine the nature of this point. And then none of this detail is helpful. So the question might look like this. Determine the nature of this turning point. And you need to determine whether it's a minimum, a maximum, or point of inflection. But notice the question might not mention that. They might just use this word nature. And by nature of the turning point, the question always intends to ask about whether it's a maximum or minimum. Okay, so we always use the second derivative. I hope you found that helpful.